Hi guys, we are Team 5. Our team members are Jinyoung Kim, Sung Kim, and Jung Chu. We're gonna present progress presentation about search on the replay buffer. Let's start. Search on the replay buffer is a machine learning algorithm that learns to make decisions to reach goals. To reach goals, there are two broad classes of algorithm, planning and reinforcement learning. Planning algorithms effectively reason over long distance, but have a limitation in high-dimensional observations. Reinforcement learning is good at learning policies and the relative value of states, but fails to plan over long distance. Search on the replay buffer attempts to combine the best of both algorithms. In more detail, planning algorithms effectively solve long horizon tasks. This algorithm assumes that we can effectively sample valid states and estimate the distance between two states and acquire a local policy for reaching nearby goals. This assumption makes it hard to apply this technique to high-dimensional tasks like image observation. The next is goal-conditioned reinforcement learning. The agent failed to reach distance goal, but if agent start nearby goal, it can successfully reach the goal. But how about making bridges between start and goals? This is about replay buffer. The agents use observation to make waypoints leading to the goal. And it uses agent value function to predict when two states are nearby. And it builds the corresponding graph. And finally, the agent run the graph search to find the sequence of waypoint with a goal conditions policy. You can see the blue line that agents successfully find the goal. And here is algorithm summary. This algorithm combines graph search and goal conditioned reinforcement learning. You can see the functions to search policy with shortest path function and checking max distancing. And on the right, the algorithm uses Dijkstra algorithm to find the shortest path. Our implementation approach are two ways. The first is using A-star algorithm instead of Dijkstra algorithm. The second is ensemble value function with different max distance. Sung Kim will tell you more detail. Thank you.
Hi, this is the second presenter, Song Kim. I will talk about our progress. We have succeeded to implement a SORP algorithm as shown in this figure, referring to the author's code. Here we use distributional DDPG algorithm to train the agent. After replication, we have tested how the graph is constructed from each value function. This figure shows a constructed graph from different value functions. The edges represent a path with less than distance 7. These graphs will be ensembled when we compute the waypoint. And this figure shows the waypoint computed from planning algorithm given on ensembled graphs from each value function. The red cross symbol represents the start position, the green star represents the goal position, and yellow square represents the waypoint. As you can see, the waypoint successfully bypasses the wall and reaches the goal. And here is our original improvement plan. We firstly plan to use A-star algorithm to look for a better path quickly. We also plan to ensemble value function with different max dist, hoping that it'll give sparse waypoints for simple path and dense waypoint for complex path. But when computing the waypoint, shortest path algorithm is called every time for all pairs. So it is inefficient to use single source shortest path algorithm like Dijkstra's algorithm or A-star algorithm. In the implementation, all pairs shortest path algorithm like Floyd-Warshall algorithm is utilized. So our original plan to use A-star algorithm is impractical. We will reconsider how to improve the planning algorithm later. And regarding the second plan, we have tested how maxdist hyperparameter affects to the waypoint. The left of each figure shows the naive policy from DDPG, and the right of each figure shows the policy from planning algorithm. We increase MaxDis hyperparameter from 7 to 10. As it increases, waypoint becomes more sparse and the agent follows much shorter path, although it fails when it is too sparse. However, the problem is that MaxDis is used after training the value function, so we cannot ensemble value functions with different MaxDis. We will also reconsider the way of adjusting sparsity of waypoint depending on the degree of difficulty.
I'll explain the modification from the original plan. Since our original project plan have some problems, as we explained before, so we are planning to do other ideas during the last 4 weeks for this project to make more improvement on the reply buffer for the planning algorithm. First one is that path difficulty is depend on the distance function between start and the end point in this 2D navigation problem. However, if we proport the distance between start and end point to effect to the more dense waypoint, if the start and end point is closer, then we can set more dense waypoint, and it can able to the trainer can find the path more easily. However, if the start and the end point is far, it means more difficult, then we can set more relaxed waypoint in the larger lane point to search more broad way to find the path, because you see our result before, then some points the agent cannot discover the endpoint and it is converged to the edge of the map. So we are planning to do giving the different dense waypoint depending on the difficulty. It means the distance, and also we can find other different distance function to set difficulty in new ways. It is already the author in the paper mentioned the distance function is very default for this agent. And moreover, in this paper, the replay buffer is the very key idea. And if we can first, in this paper, they are fill the replay buffer in the map with the random data. However, if we can first using the simple planning algorithm to find more high probability way and fill more dense replay buffer for that area, then this agent can reach to the other buffer more easily. So we are assuming that it will, and it is more efficiency than others. And also they have a various navigation environment as you see in this slide. And also the difficulty of the map, it means that if the starting point to end point is just one way and they have various ways to go, it means the different replay buffer can affect to the efficiency and the trainer's accuracy. So we can try the other map to see how replay buffer affect well to finding the path. Thank you very much.